All right, good morning, everybody. I hope you're all well and I hope you all had an amazing day yesterday. Welcome to the STEM Lockdown Digital School. I hope you find today's lesson fruitful and productive and very, very informative. Just to remind you who I am, I go by the name of Karabo Khashani. On Instagram, I'm KB_Khashani, and on Facebook, Karabo Fiona Khashani. It is always a pleasure having you guys, and this is Natural Science Grade 6. Please do remember to follow us on all social media platforms. All right, and without wasting any time, let's get straight into it. All right, so at the end of the lesson, we are going to discuss what is electricity. So by the end of this lesson, you should fully understand what electricity is. We're also going to know how to construct a simple electric circuit. All right, how exciting does that sound? We're also going to know what the electric circuit components are. All right, so what they include of and what they are. We're also going to know the function of each circuit component. All right. We're also going to know the differences between a closed and an open electric circuit. All right, so just to obviously just give you a brief, we are discussing simple circuits. So starting from today, we're going to just be talking about electricity right through towards the end of this week. We're going to obviously move on from simple circuits to closed circuits and on and on and on. So please do stay tuned to all of the lessons as it is going to be a continuation and I wouldn't want you to miss out on anything. All right. Please remember if you do have any questions for me, just type it in the Q&A and I will have a look every now and then just to see your responses and just to see that we're on the right track. All right, awesome, let's go. All right, so let's do an introduction. Now, if we think of the world that we are currently living in, one of the things that we encounter every day and almost everywhere is electricity. Now, I'm pretty sure that most of you, wherever you are, you have electricity running in your homes. Now, unfortunately, that's not the case for many South Africans, all right, in our country. Some homes do not have electricity. You know, they're relying on coal and fire to cook and for lighting. So, you know, we are just amongst the lucky few that actually do have electricity in our homes. A lot of you are watching through your laptop screens. It could be your cell phone, laptop, whatever it is. But obviously those gadgets are being charged, all right? Like mine right now is actually being charged, and that's the use of electricity. You know, you've got your fridge running in the kitchen, maybe the TV is on, maybe your cell phone is charging, whatever the case may be. All of those appliances need electricity. All right, now I want you to imagine what your life would be without electricity. So in your Q&A, give me just a little thought of how your life would be without electricity. All right, and I will have a look at those just throughout the lesson. All right, so please, first question for today, what would your life be without electricity? All right, so the words that we're going to be discussing are an electric circuit and electric current. So these are your new words. I would suggest that you write them down and in your spare time for homework today, write down the meanings of each of those words for better understanding. All right, so like I said already, electric circuit, electric current, component, a device, appliance, battery, and switch. Those are the new words for today. I'll just give you about 30 seconds just to copy down those words and you are going to find the meanings for me and we're going to discuss the meanings tomorrow. All right, so 30 seconds starts now and I'm going to check your Q&A so long. All right, nothing as yet. All right, cool. No problem, guys. All right, so just remember that those are your vocabulary words and We will go over the meanings tomorrow, all right? I hope you've all copied down those meanings, and we're moving on. All right, electricity. All right, so I would like you to name and draw, all right, but let's just stick to naming for now, 5 appliances, or uses in your home that need electricity to work. So look around you where you are right now. What is in your home that needs electricity to work? I've given you my examples already. I've got my fridge, TV, the microwave, the kettle. What about you? What is in your home that needs electricity to work? All right, I will have a look at those answers shortly. Right, the next thing, I would like you to name 5 applications or uses of electricity in your neighborhood. So now think about the area that you live in. All right, what is it that electricity is used for in your neighborhood? All right, think about your neighborhood. All right, maybe some of you live in very secured areas with maybe like an estate with boom gates or electric gates for you to enter into the home, your robots. All right, so just think of 5 uses of electricity in your neighborhood. So first it's your home, the second one is your neighborhood. All right, and then the third one, name 5 uses of electricity in your school. All right, so we haven't been in school for quite a while now, and I hope some of you haven't even forgotten what your school looks like. So just to give you a memory, just try and think about your school from the moment you walk into the school gate to walking to your classroom or to the fields to play with your friends. Think about how is electricity being used in your school. All right, so think about the teachers, the staff room, the office, all right, all sorts of places that could use electricity. All right, so that's your tasks for today. You're just going to type those in your Q&A and you're going to tell me how is electricity used in your home, in your neighborhood, and in your school. All right, awesome stuff. All right, and lastly, I would also like you to please tell me, why is electricity important to you? Why is electricity important to you? All right, why is it important to you? Just 30 seconds to answer that. All right, I see Shakira says we use electricity a lot now, so it would be very difficult to do anything. I agree with you 100%, especially now because we're all at home during this lockdown. We are using electricity more than ever. All right, our TVs are on most of the time. We're always charging our phones because we're playing games and the batteries are flat. So I agree with you. I don't think we've used as much electricity as we are now. When we're all at school and at work, the house is mostly empty and not much electricity is being used. Whereas now, because everybody is home, we are using so much. That's a very good point, Shakira. Well done. Thank you for that. All right, 100%. All right. So JD says it will be boring and I will be more active. Well, that's a good thing. Well, look, yes, it would be boring without electricity, but you would be more active. And I think I would be too, maybe skipping or running or, doing something just to maintain a good health. All right. Maddie says the lights, very good. They use electricity. All right. We have Shakira saying the washing machine. Shakira says street lights, very good in the neighborhood. Street lights use electricity. TV, smart boards in the school, very, very good. Shakira says I need to warm my food, obviously with the microwave. Lita says fence, I'm assuming could be an electric fence, all right, which needs electricity. Our phones to cook. And Lita goes on to say TV and hot water. All right, thank you so much, guys. So now just imagine the amount of hot water we use because we're at home all the time. You know, the TV is always running. That's a lot of electricity that is being consumed. Thank you much for those answers, guys. All right, let's move on. All right, so I asked you, why is electricity important to you? Please also tell me, why is electricity important for your city or your town? So wherever you live in, if you're in Johannesburg or if you're in Durban, wherever you may be, why is electricity important for your city or your town? Right, please do type that in your Q&As. And lastly, why is electricity important for your country? I'm really excited to see some of your answers for this. You know, why electricity is important for your town and why is it important for your country? Give a think about it. I'm looking forward to seeing some of your answers. All right, let me see if anybody has said anything before we move on. All righty. All right, I see a lot of you are giving examples of electricity, laptops, school computers, lights, heaters, printers. Right, 100%. All right, cool. I'll give you some time to just answer those questions. But in the meantime, we are going to move on. All right, and lastly, what would you say is electricity? So what exactly is electricity? You know, I've been asking you all these questions about why is electricity important? Why is it important for your city? But what exactly is electricity? What are we talking about when we talk about electricity? What is electricity? All right. All right, so I'm going to wait for your answers in terms of electricity. We do know that it's basically just a flow of current, all right, and a flow of energy that supplies our homes, schools work with energy. All right, so for you to charge your phone, a circuit is happening and a flow of energy is happening through the circuit for your phone to be charged or your laptop. All right. Now, a simple circuit is an electric circuit, and it is a system for transferring energy. All right, so I've given you just a picture there of what a circuit looks like. So your homes are wired. There's all sorts of electric wires in your homes, and those are wires that have been installed by an electrician, somebody who knows how to connect the wires and how to make sure that there's energy flow in your home. All right. A simple circuit always has the following components. So for there to be a simple circuit and for there to have energy flowing in your home, there needs to be the following components. There needs to be a source of energy. This could be a cell, which we also call a battery. So remember those terms. Cell, battery is actually considered to be the same thing. So we're discussing the components of a simple circuit. So it needs to have a cell or a battery. It needs to have a conducting material like a wire. So just like in the picture that you see on the bottom left, there's a cell, the battery. There's a wire, which is just the red wire. All right. And lastly, a device. This could be a light bulb, a buzzer, or motors for changing electricity into useful output energy. So if you want a light, you'd have to attach a light bulb to the wire, to the battery. If you want to play a game of maybe, let's say 30 seconds and you want to have a buzzer, instead of having a light bulb, you would attach a buzzer. All right, so depending on what you need, it will obviously, the battery and the wire would supply the necessary energy. So if it's light, it would be a light bulb, and so forth. So please remember those three components that make up a simple circuit. All right, we've got a battery, wires, and a light bulb or a buzzer or motors. All right, so please do remember that. Now, a circuit is complete, unbroken pathway for electricity. So now we know that when you're able to switch on your light, it means the circuit is complete and the electricity is flowing through freely. However, if you realize that one day you're switching on your lights and it does not go on, it means there must be a broken switch somewhere. So somewhere along the lines, it could be that the battery has broken or the wire has chipped a bit or the light bulb has died. So it will no longer be called complete, right? Because it's not working. All right, so if your light doesn't go on, then obviously there must have been some sort of a broken pathway for electricity to flow. All right, now a switch can be added to break or complete the circuit pathway. Now I want you to just listen to that and listen to the example that I'm going to give you. I'm going to read that again. A switch can be added to break or complete the circuit pathway. Now, if any of you have a lamp is basically a light that usually sits on the side of the bed or, could be a lounge, just basically a lamp that supplies light. Many of our lamps have little switch that you can basically play with, on, off, on, off, on, off. Well, not play with, sorry. A switch that you can basically switch on and off, on and off. Now that switch could either break the flow or complete the flow. If you switch it on, it has allowed the electricity to flow through the wires into the light bulb. And if you switch it off, obviously there will be no pathway. It has been blocked. All right. So that is what a switch helps to do. A switch either breaks or completes the circuit pathway. All right. Very, very important. All right. Now let's talk about components of simple circuits. All right, so I just hope that you were able to just understand the previous slide that we were discussing a simple circuit. It's a very, very simple. It is inclusive of a battery, wire, and a light bulb or a buzzer. That's very, very simple. Now there's an example of a simple circuit. You might find that, it's just unfortunate that, we're not in school, but, this was the time for you to actually do and create your own simple circuits. Your technology and your technology would have asked you to create a simple circuit, and she or he would have guided you into creating your own. It could be, she or he would tell you what you would need. It could be a wire, the battery, and the light bulbs. Actually make the light bulb go on. So as you can see in that picture over there, there's just a wire, a battery, and a light bulb. All right, and obviously now the light bulb seems to be going on. Now, if I had to remove one of the wires from the battery, that would be a broken pathway. The light bulb will not go on. All right. Now, a simple electric circuit has 3 components. All right. So I would like you to remember that a simple circuit has 3 components that we are going to discuss it. All right. And I see that Shakira actually said that electricity is a form of energy resulting from particles called electrons. Right, that's a very smart answer. Thank you so much, Shakira. And then Anonymous says, because we use electric things such as television and laptops. Right, 100% correct. Alrighty. All right, so a source of energy such as a battery. So now we know that 3 components. First one is a battery. Conducting materials such as electric wire. So this is just very, very similar. In fact, it is the very same as the previous slide as to the components of a simple circuit. All right. And a device that transfers the energy for a useful purpose, such as the bulb that provides light. So those 3 components are a battery, electric wires, and a device. Now, a simple circuit is a circuit, is the path that an electric current travels on, all right? And obviously that is a simple circuit where actually the current, right, being the electrons that Shakira mentioned, is exactly what the circuit helps to supply energy. All right. Now, these 3 components are necessary to have a functioning electric circuit. Now, if you don't have any of these 3 components, the circuit will not be able to function. If there's no battery, there will be no energy flow. If there's no wire, there will be no energy flow. So you need all three components for the circuit to be complete and for it to function. All right, so like I said, you'd obviously need a source of voltage, which would be your battery, a conductive path, that could be a wire, and a resistor, a light bulb or a motor, all right, or a buzzer. Right, moving on to the next slide. All right, now on your screen, what we have is basically what scientists have actually, because they figured that it would be very, very hard for people to draw a light bulb and to draw a switch and a battery, because we're not all actually artists. Some of us are really bad at drawing, like myself, extremely bad. So the picture that you see on your top left over there, that is actually what scientists thought it would be easier for us to draw. Basically, it's just a circuit made up of lines using a ruler. It has to be completely straight using a ruler. It's never actually, just freehand drawn. It's always a square with your ruler. Now I want you to look at that. I would like you to just look at that top picture, and you can see that there's a switch. All right. Then towards the right, just moving to the right, there's a light bulb. Then it has actually shown you the wire and the battery. Now look at the picture at the bottom. So a light bulb, as you can see, it's yellow, but in the scientific drawing, it's just a circle with a cross in the middle. So that's how scientists have defined a light bulb. A light bulb is a circle with a cross. Now look at the switch. The switch is just like a little open lever of a sort. All right, showing that the switch is open, the light bulb is on. And now look at how they've drawn the battery. The battery is just one long line and one small line parallel to each other. And the wire is just obviously the black line that you see that has made the rectangle. All right, so if you are asked to draw a circuit, that is exactly what you would draw, the picture on the top. That is a circuit that you would be required to draw. All right. All right, now over here is basically just an overview of what the symbols actually look like. So like I said already, it would be very, very hard to draw a battery or a wire or a light bulb, because just like me, I really cannot draw. So we're going to start off with the top line. All right, it says component, symbol, purpose, and an example. So now scientists have found very smart ways for us to draw these symbols. The first one is a cell battery. Now look at the symbol. All right, it's the wire and obviously attached with a big line and a small line showing the positive and the negative. Right, so that's basically the symbol for a battery, a long line and a small line. I hope you're drawing these symbols down in your notebook just so that you can remember what the symbols look like. And what does a battery do? It provides electrical energy. Now on the far right is a perfect example of a battery. That's exactly what a battery looks like. But because I cannot draw a cylinder, I would rather just draw what the scientists have drawn, just a small line and a short line. The next one is a power supply. All right, so now power supply is shown by two circles. All right, and the purpose is it is an alternative to using cells. All right, so if you don't have a battery but you've got a power supply, you could just draw that, and there is an example of a power supply, a box with a lightning sign, I would say it is. Right, the one in the middle is wire. Wire is reflected by just a straight line. A straight line, wherever you see a straight line, it is a wire. And what does it do? It allows current to travel. And there is a picture of a wire. Then a light bulb. A light bulb is shown by a circle with a cross in the middle. And what does a light bulb do? It converts electrical energy into heat and light. And there is a perfect example of a light bulb. I definitely would not be able to draw that, so I would rather just draw a circle with a cross in the middle. Then there is a motor. A moto is actually very similar to a light bulb, but instead a moto has a M in the middle, a circle with M for moto in the middle. And what does a moto do? It converts electrical energy into movement energy. And there is an example of a moto. All right, I'll give you just 5-10 seconds just to make sure that you've copied down those symbols and what they are. So a cell battery, just the symbol, the power supply, the symbol, and so forth. All right, just 15 seconds while you copy those. All right, and I see Anonymous says it is important for our city to have electricity because of communication and to get information. Oh, that is a beautiful answer. Right, mini substation. Ooh, okay. Because we need to communicate with each other. Right, 100%. So we definitely need electricity in our cities, obviously, to be able to communicate. All right. Okay, I hope you've all just copied down those symbols. All right, moving on. All right, so the last two symbols is a buzzer. That is basically how you would draw the symbol of a buzzer. And what does a buzzer do? It converts electrical energy into sound energy. Right, and there's an example of a buzzer. Looks something very similar to a speaker. Right, I've seen a lot of those signs actually on my laptop or something. All right, and the last symbol is a switch. All right, as you can see, that is an open switch because it's lifted up and it allows circuits to be opened or closed. If the switch was closed, that line would have been onto the circle, wouldn't be that space, would just be a complete straight line. All right, and there's an example of a switch, all right, that I really would not be able to draw. All righty. I hope that you've copied the last two symbols down and we're going to move on. All right. All right, we're going to do a bit of an activity. All right, so I'll definitely just give you a couple of seconds to answer. We need to match the picture, so 1, 2, and 3, with the pictures on the right. So we need to match the pictures on the left with its scientific drawing on the right. Let's look at number 1. By my understanding, number 1 has 2 light bulbs, a wire, and 2 batteries. Okay. Now just make sure that you are looking at where the positive is and where the negative is of the battery to identify it to the correct scientific drawing. So what is the answer for number 1? Is it A, B, or C? Please match number 1 with its correct drawing. Is it A, B, or C? I'm going to give you a couple of seconds to just have a look. All right, while I wait for your answers, let's look at number 2. Number 2 has a battery with positive and negative on the left and right. It has a moto and it has a switch. Which scientific drawing does it match to? A, B, or C? And number 3 has 2 light bulbs, a wire, and 1 battery with a negative charge on the left and a positive charge on the right. Which scientific drawing does it match to? A, B, or C? I'll just give you a couple of seconds to answer that question. So maybe in your answers, you can just write 1 A or 2B or whatever the case is. Right, and I will have a look at that. All right, let's see. All right, so JD says 2C, 1B, and 3B. All righty. We've got Karabo who says B. I'm thinking that is your answer for the first one. I'm thinking that you're saying 1B. Just correct me if I'm wrong. Apile says 1B, 2C. We've got Apile who says 3A. Luandle, 1A. All right, Karabo says 1B, 2C, 3A. Okay, cool, guys. And Shakira then says 1B, 2C, 3A. So Shakira and Karabo pretty much the same. JD, 3A. All right, I'm going to give you just 10 more seconds to see if any of you still have any more answers before we move on. Just a couple more answers. All right, Shakira, 1B, 2C, 3A. All right, Madidi says 3A. Bonte, 3A. Jaden, 3A. Lita, 2C. All right, cool, guys. Thank you. Let's have a look at the answers. All right, we've got 1B. So 2 light bulbs and the 2 batteries. Now look at the symbols, the positive charge, negative charge, positive charge, negative charge. Now you need to remember this, guys. So if it's positive, the positive is always the long line, negative is the short line. So now because number 1 has 2 batteries, we draw the first positive charge, which is the longer line, and the small line is a negative charge. Right, so please remember that positive, long line, negative, short line. All right, so number 1 is B. Well done to those of you who said B. Awesome. All right, and we've got 2C. All right, so 2C. So now with this one, they've kind of changed the direction of the scientific drawing, and you might find that they're actually going to do this in your test or activities, that you don't have to draw it exactly the way it is. You can actually just switch things around as long as all the components are there. So 2C has a battery, negative, positive first. So positive, big line, negative, small line. There is a motor, which is shown by a circle with an M in the middle, and there is a switch. Now, because that switch is open, that little line goes up, if you see that, just over here where my mouse is, right, just over there, that switch is open. If it was closed, this line would have just been completely straight. All right, and last but not least, of course, it is 3A. All right, it's got 2 light bulbs and 1 battery. But look at that battery over there. All right, it's negative, then positive. So you need to draw it like that. Negative, small line first, positive, big line afterwards. So please, please, please remember that. A positive is always a longer line. The negative is the shorter line. And draw it in that order. Don't switch it around, because if it's in a test or an exam, you are going to lose marks. Right, that was a pretty fun activity, and most of you actually got that correct. Well done. Right, so it is 1B, 2C, and 3A. All right, 100%. All right. All right, I see Lita saying yes. All right, well done. Well done, well done, well done. All right. So now this is actually your turn. Now, in your spare time, I would like you to use the symbols. So the symbols that you saw previously on my previous slide, and you need to draw a circuit. Your circuit has to have a power supply and a battery. So you'll need to go back to the previous slides, and I hope that you've drawn them in your notes. You need to draw a circuit with a power supply and a battery. All right, obviously we'll not be able to see your drawings, but please do try this at home just to see that if you do understand, and we will go over the answers tomorrow. A power supply and a battery. Number 2, draw a circuit containing a switch, a motor, and 3 bulbs. Now, I didn't say if it's an open switch or a closed switch. So for number 2, we will make it an open switch. So number 2, an open switch, a motor, and 3 bulbs. Number 3, you need to draw a buzzer, a closed switch, and a motor. So please draw those tomorrow, well today for tomorrow, and we are going to actually go over those answers tomorrow, and I will show you the pictures that I have drawn. So number 1, a power supply and a battery. Number 2, an open switch, a motor, and 3 bulbs. Number 3, a buzzer, a closed switch, and a motor. Please do draw those. Remember to just draw a circuit using a ruler and a pencil and make it as accurate as possible. You should have 3 different drawings. They don't have to be big, maybe just about 5 lines of your page, all right? So that is power supplies. I'll just give you just a couple of more seconds just to copy that down. And we'll go over those answers tomorrow. Awesome. All right, so here's just a takeaway message. Electricity supplies light to many homes across the world. So a lot of people depend on electricity. Some people do not have access to electricity. We need to realize that that is the reality of our country, that some people do not have any electricity at all. All right, so you are all very, very fortunate to have electricity running in your homes. All right, here is some helpful links for you. A simple circuit. This is just a video of a simple circuit being made on YouTube. Secondly, another one on how to build a simple circuit. You can just follow that website. And another one also how to build a simple circuit. All right. All right, so tomorrow we are going to be discussing circuit diagrams. All right, so today you just got a brief introduction on circuits and how they are to be drawn. Tomorrow we are going to discuss circuit diagrams. All right, for more information, please do contact me. And also please remember to follow us on social media, and all the links are there. All right, I'm just going to go over your Q&As before I end this lesson today. So if you've got any questions, please just type them down in, and I would address them before I hang up or tomorrow. So we've just got about 4 more minutes just for sessions on questions and to address any uncertainties. All right, just scrolling down. So I'll give you just a couple seconds to see if you guys have any questions regarding today's lesson, and please do tune in tomorrow. All right, I see Denero. Denero is asking who created a light bulb. That's actually homework that I should be giving you, Denero, all right? But I don't know if any of you have heard of Thomas Edison. Now, Thomas Edison, very, very long ago, he actually invented a light bulb. So maybe you can just read up about him and you can actually find out as to how he even began to create a light bulb. Right, so a man by the name of Thomas Edison. All right. Awesome, guys. Thank you so much for participating in today's lesson and tuning in. You've all been amazing. Thank you all for your answers. And I will see you guys, we will see each other again tomorrow. Have an awesome day. Please do your homework, and we are going to discuss that tomorrow. All right, goodbye, everybody.